All right, welcome back to Module 3, our U.S. Postal System or U.S. Postal Service network analogy. I love teaching this because this, to me, is a very fundamental way of breaking down this complex thing we think is called networking to something that most of us know and live with every day, the U.S. Postal System. That's right, the U.S. Postal System. So when we think about networking, it was built upon on the backs of something, like I say, that already existed, was the Postal Service. So what we're going to look at is how the analogy, and really we're going to be just focusing on these three layers. We just finished the OSI model, right? So we're really going to focus on the last three layers, or the first three layers, or whichever way you want to look at it. Layer 1, physical; layer 2, data link; and layer 3, the network layer. But to help, hopefully, at the end of this, give you a better appreciation and a little better understanding of the simplicity associated with networking. Really, it's just transportation. Think of it that way. Transportation. How do we move something from point A to point B to point C? All right, so to start this off, it comes down to two people. My house and my grandmother's house, okay? So I live at 111 Nate Drive in Dallas, Texas, okay? That's my house. My beautiful grandmother that I love to death, she lives at 225 Penny Avenue in Dallas. Now, if you look, we're at the same zip code, 75023, and she's at 75023. So yeah, she's right here in the neighborhood. Now, my grandmother loves to get letters. People from that generation, email wasn't a thing, so they love letters. So I always like to write my grandmother a letter about once or twice a month, okay? So what do I do when we're going to write a letter? No different than anyone else. You write the letter, you encapsulate it, or you put it into an envelope, and you put two things on, or actually three things on that envelope. You put, I put her address, right? That's the receiver address, or the destination address. I put my address, that is the sender address, and yeah, got to put a stamp. Got to put a stamp. So those are the things that I will put on that letter before I mail it. A source, and if I was talking about it from an IP perspective, that sender address would be the source, and that would be the destination. All right, source address, destination address. That's what we call it in the IP world. In the mail, we just call it, this is, the recipient and the sender. Okay, so when we think about addressing, and no different than we have set up, the U.S. Postal System has set up a protocol on how things are to be addressed, right? The name, the street, the city, the country, the city, the state, and the zip code. Well, with IP, with the network, there's a very similar protocol that we've established. It's called the Internet Protocol. We're using version 4. We're moving to version 6, IPv6. For the purpose of this class, I'm just sticking with IPv4. I may do another course later on to talk IPv6 and get into that a little more. So when we think about the protocol that we use for IP addressing, it is based on a 32-bit number, 32 places, 32 bits. So, that's 32 bits long. Now, if you had to give somebody your address, like here, what is my grandmother's address? 225 Penny Avenue. Pretty easy. If I had to give somebody my IP address and it was 32 characters and they were all ones and zeros, that would get a little annoying, wouldn't it? If they, well, what is your IP address? 1101100100110011101. Did you get that? No. So to help that out, we do what we call dotted decimal. Basically, we take those 32 bits, break them up into octets, 4 octets of 8 each. If you do the math, 4 times 8 is what? Yes, somebody out there said it, 32. So we got 4 octets that we break it up into groups of. So when I look at this, now I do what I call dotted decimal binary, where I can convert each of those octets to its decimal value. So if I look at this octet, 11000000, that would translate to 192. This next octet would translate to, 168. If I do the binary conversion, which I'm not going to do here, and I can keep going. So now, instead of saying this long number of 32, I can now tell you my IP address is 192.168.1.15. Makes it much easier to communicate, but it's still the same protocol, just no different than we have a protocol here by the U.S. Postal System. We have a protocol set here by the IETF. It's an organization, a consortium that came up with this IPv4 protocol, as well as there's an international consortium that has come up with the IPv 6, IP version 6 protocol. Okay, so now that I've got my letter, I put it in the mailbox. The postman comes by in his little truck. He picks that up and he takes it to our local post office. That's my local Garland and Dallas area post office. Now, for that is analogous to layer 1, the physical layer, the highway that truck had to travel to get there. Analogous to, the copper cable, the fiber optics, the Wi-Fi that's actually having to move information, data, bits from point A to point B. Okay, so that letter gets to my local post office and they do something pretty interesting. They look at the zip codes of the sender address and the recipient's address. And they say, you know what? That, my friend, is the same zip code. Then they know that that is a local delivery. So what they can do is put it on another truck and send it right to my grandmother's house because the zip codes are the same. That is analogous to layer 2. That's what your switch function, the layer 2 switch. So when your PC sends information and the switch says, hey, I recognize this, this MAC address, this media access control address, and you're trying to go to the printer, okay? So I don't have to do anything except take that and route it right back to the printer. And now my computer can talk to that printer. Local, just like a local delivery. Okay, that's layer 2. That's at the data link layer. So that's what we call LANs, a local area network. This little picture here depicts a local area network where these local devices can talk to each other locally across that layer 2 switch device. LAN. All right. One day, I find out that my grandmother moved to California. Yes, she just up and left Dallas. And she went to 3345 Sunny Beaches Cove, Los Angeles, California, 90210. All right, so but I still love my grandmother and I still want to write her letters. So what do? I do the same thing that I always do. I send my letter to my local post office. But what do? They look at the zip codes and go, wait a minute. Wait a minute. Something's different here, okay? So now we recognize 75023, that's us, but 90210, we don't know where that is. So now they have to do something with that letter, okay? Something we call routing. So what they're going to do is they're going to put that letter on a plane, and they know what they have routing tables. It's a book that says, or now it's actually a computer, that says that this letter needs to be routed. So they send it to St. Louis, to a postal hub, to a postal center. And that postal hub now knows that, 90210, I know exactly where that is. That is in San Bernardino, California, and it sends it to the local post office in San Bernardino, California. And then once it gets there, it's a local delivery to my grandmother's house. So a couple of things have happened here. So I've had to use what we call a network now. So this is really analogous to layer 3, where I have to route. This letter had to be routed from Dallas to California. Okay, so and to get there, it had to be, like we use an IP address, it had to use the address or the zip code to know how to get there. So what I had 2 local area networks. The one that here in Dallas, and I have a local area network here in California. But you see, they're disparate. They don't know how to talk to each other. They have no idea how to talk to each other, which is why we need layer 3. This is why we need a router. The router is smart enough to know that, hey, I can send information from one local area network to another local area network. No different than the U.S. postal system. This is how things move across our internet day to day, is being routed through a layer 3 type of device. So as you see, actually, the U.S. postal system was much smarter than they probably even thought they were themselves when they came up with this concept of how to move information, how to move data from one place to another, how to route, and how to do local deliveries. And our network set up on the same concept. Hope this helps you give you a little better understanding of this simple thing that we call the network. Okay, let's get ready to go into Module 4. Have some more fun with this.